Hey, Megan. Abelie said, Megan wants to know if you will record the homework. So we have questions on 28 and 34. So we're going to go over 28 and 34, and then we'll continue on notes. Let me cheat off of Remington. Oh my goodness, this is crazy. All right, 8x minus 3y x cubed y to the 4th times 6xy to the 8th. And I lose my spot every time. 24x minus 9y. Okay, here's the deal. Let's talk about this real quick. We don't have to keep flip-flip because he's multiply, right? But let's talk about what's trapped and what's not trapped. Like stuff that has to go together. Like the 8x minus 3y. Is he trapped? Yes, because he's minus. Same thing with this guy. He is minus. These guys, though, x cubed y to the 4th, he is not trapped. So we can cancel any of these guys with any of these guys, right? Because those are not trapped. So we've got kind of a combination of trapped and not trapped here. And let's do some things. So this 8x minus 3y, is there anything I can do with that? Like, can I pull anything out? Can I difference of squares him? I don't think so. What about this 6xy to the 8th? Can I do anything there? No. X cubed y to the 4th? No. What about 24x minus 9? Why? I can take out a 3. Okay, let's do it. Take out a 3. Left over would be 8x minus 3y. Hey, there you go. All right, let's cancel that stuff. Cancel, cancel. Those two will cancel, right? Those two groups. All right. Now, we could cancel some other stuff, but I'm just going to do this. I'm going to do a cleanup step. You can cancel some more stuff if you want to, but I'm going to clean this stuff up, okay? Now, on the bottom, so I've just got that 6xy to the 8th on the top. What's the bottom going to be now? I know I'll have that x cubed y to the 4th, but then I also have this guy 3. Okay, now from this, let's simplify him. So 6 and 3 I can cancel, right? And have just 2 on the top. Okay, what about the x's? Can I cancel those guys? And how many will you have? 1 on the top, 3 on the bottom. 2 on the bottom. Okay, y's, 8 on the top, 4 on the bottom. 4 on the top. Am I done? That's it. You're right. I said 4 and then I wrote 8. Thank you. There you go. Okay, happy with that? Ish. Maybe not happy with it, but that's how it goes. Holy schmoly. This one's even worse. 34. Okay, says this. 3y squared plus 21y plus 147. 147 over 25y minus y cubed divided by y cubed minus 343 and y squared minus 12y plus 35. We got lots of stuff going on here. Okay. All right. I know that since I'm dividing, I'm going to have to keep flip-flip, right? Okay. So we'll keep him in mind. We'll keep flip-flip him. But let's do this. Let's break down some stuff going on here, right? So this top guy, what can you do? Pull out a 3. Okay. I'm going to pull out a 3 first. And I'll have y squared plus like 7y plus 49. No, is that right? Ugh, really? Is that really 49? Gross. Okay, that looks like a simple trinomial, right? Y squared plus 7y plus 49. Can you multiply to get 49, but when you add them, give you 7? 7 and 7, but that won't give you 7 when you add them. And 49 is only 1 and 49 and 7 and 7. I don't think he will break down anymore. So I'm going to write him down. 3y squared plus 7y. That one won't break down anymore. He's done. Okay. All right. Let's talk about what's right below him. 25y minus y cubed. What can you do there? But this one has a y here. So just take out y. Can we take out a y? Okay, here's what I'm going to do. You ready? I'm going to take out a negative y. Can I do that? Okay, if I take out negative y, this is negative 25 plus y squared. Or negative y times y squared minus 25. You see that? I took out a negative y and I flipped it. Okay, but then there's one more thing. What's y squared minus 25?
Y.
Minus 5 plus 5. Okay, and then don't forget about your minus y here. Cool. Okay, he is done. Yeah? All right, now I'm going to switch this to multiply. And this guy up top here is going to go down to the bottom. I'm going to flip him at the same time I'm breaking him down. Can I do that, or is that confusing? Okay, what is y cubed minus 343?
Difference of cubes.
Difference of cubes, okay? Whoop. Difference of cubes is a minus b. A squared plus ab plus b squared, right? Okay, y cubed minus 343. All right, what will a be? If I take the square root of that guy. A will be y and b will be, what's the square root of 343?
6, maybe 7.
7?
Is it 7?
Is it 7? I think it's 7, actually.
No.
7 times 7 is 49. 49 times 7 is 343. That's right. Yeah. Okay, so what will this guy look like?
So
Y minus
y minus
7.
Oh, it goes on the bottom.
Okay, and it goes on the bottom. Don't forget this is going on the bottom. Okay, what will your a squared be?
Y squared.
Y squared. What about your b squared at the end?
49.
49. Okay, and in the middle plus a times b. 7y. Oh, look at that. Fancy. Okay, real quick, before we cancel and do all the things, this guy in the bottom here is a what? Simple trinomial. Multiply to get 35, add to get 12. Negative 12. 5 and 7, both
Oh, yeah. Negative.
negative. Y minus 5, y minus 7. Oh, man, this is going to be nice. All right. This big piece cancels with that big piece. Yeah? Okay, what else?
Y minus 5 and y.
Y minus 5, y minus 5. What else? Y minus 7, y minus 7. Is that it? Okay, what's left on the top? 3 on the bottom?
Negative y.
Negative y times
1.
y plus
Oh,
5.
plus 5.
Is that it? Done. Boom. Look at that. Breaking them down is really rough. You just got to figure out what each one of them is. That 25y minus y cubed was a really weird part. Mm.
So on
Yeah.
22, I broke it down, but do we just like, it's
22. 22, let me see. 12 plus 4 cubic root over 8, like that?
yeah,
Okay, what'd you do?
12 over 8 plus 4,
12 over 8 plus 4,
and then the cubic, and then
and then over 8.
do we just add those?
You're just gonna reduce these guys and reduce those guys. Yeah, yeah. So 12 and 8 would be 3 over 2. 3 halves. Plus, this 4 and 8 will reduce 1 square root of 3 over 2. And you don't necessarily need the 1, so that would just be square root of 3 over 2. And I think they have you leave it like that. You could shove it back together if you want to and do 3 plus that over 2. But leave it apart. Leave it apart.
It has to be a part.
It doesn't have to be apart.
Oh.
You can leave it. Whatever. However you want to do it.
Okay.
They're both the same. Or they're both correct. So, either way. Okay? All right, anything else before we move on? All right, let's do some adding, subtracting. These guys right here. Oh, and then we're adding to that today. So, adding to this, how much do we have left? Adding, subtracting?
Like half.
We have, yeah, we should be able to get done today. Okay, so in addition to those guys, we're adding here 44, 48, 56, 58, 70, and 76. There we go, those guys. Okay. Yeah. Okay. All right, and I kind of have a mess over here. Whatever. All right, we are starting adding and subtracting. Rational. What's a rational expression, by the way? I keep asking that question. Adding and subtracting rational expressions. These are all these two guys are rational expressions right here. So what's a rational expression have to have? What makes those two things rational expressions? Like if they say a rational thing.
A number has.
Yeah, like something over something, right? Like two polynomials. A polynomial where typically where you have a variable on the bottom, right? That's a rational expression. Okay. So yeah, now we're adding and subtracting. Doesn't adding and subtracting usually come before multiplying and dividing? Like they usually in elementary school teach you add and subtract before multiplying and dividing.
Yeah.
Why do they go backwards on this?
Because this is stupid.
Because why is adding and subtracting stupid?
You have to find the
Common denominator. I'm gonna put that in big. Common denominator. You do not need a common denominator for multiplying and dividing. You just break down and do the things, right? But for adding and subtracting, you have to find a common denominator. Okay. Okay. All right. Okie dokie. Here we go. We've got this, and our denominators are 4a and 10a squared. All right, so let's just deal with the numbers. 4 and 10. What's a number that both 4 and 10 go into?
20.
20. Sure. Okay, so let's do 20, and let's do 20. How many a's do I need? Do I need 3?
Yeah. Well,
I want like this is something called the least common multiple. So I want the smallest number, right? Like, okay, so here's the deal. Like 4 and 10, I could have done 40, right? And used 40 as my number, but that's not the smallest number that I need, right? Here, if I do a and a squared, I could do a cubed, right? But can I do smaller than a cubed? A squared, right? Can I do a squared? Now let me ask this question. Oop, I just erased them all. Come on, come on. Okay, if I do 20a squared, why are you doing that? Will 4a go into 20a squared?
Yeah.
Yes. Will 10a squared go into 20a squared? So then we're good, right? Okay, we don't need the a cubed. All right, so now we start with our tops. Our tops were 7 and 11. And then what I'm going to do is I'm going to put on here what he will need, right? Like, what does he need? So to go from 4a to 20a squared, what do you have to multiply by?
5.
He needs 5a, so I'm going to put 5a in the little bit here. That's what he needs to be multiplied by, okay? Now, to go from 10a squared to 20a squared, he needs 2, so I'm going to put 2 here, okay? All right, now I'm going to simplify some stuff. Whoop. What is 7 times 5a?
35.
35a, and what about 11 and 2?
22.
22. So if I put them all under one roof, that's the last step. What's the top look like? Can't combine anything.
35a plus 22.
Yep, 35a plus 22, I can't combine anything. And the bottom is
28 squared.
28 squared. That's it. That's what he looks like added together. Do we remember this? It's been a hot minute. Like we did this in Algebra 2 at the end of the year. Yeah? But this is exactly the same method that you use when you're adding like 1/2 plus, you know, like 3/5, right? You find your common denominator, you multiply by what he needs, right? Okay? But it's the same thing, but just with variables now. Okay? All right, let's do this one. Ooh, subtract the rational expression. Ooh. Okay, here we go. Here's what I want you to do. You ready? Anytime you're subtracting, this guy, I want to change him to plus, and I'm going to drag my thing through, my negative through the end of it, so we don't forget it later on. So I always change my subtraction to addition, but I drag my negative through. Always do that just whenever you see subtraction, so you don't end up bumming a negative. Okay? All right, what are we going to do first? We have to find a common denominator, right? But these two guys, ugh, what can we do there? Let's simple trinomial. Let's break them down. What can you multiply to get 3, but when you add them, give you 4?
3 and 1.
x plus 3x plus 1. Okay, what about the other one? He's a simple trinomial also.
Plus 3x minus.
X plus 3x minus 1. Okay, now we have our two pieces that we're adding together since we changed that minus to a plus. Okay, and we have to find a common denominator. Okay, what's your common denominator going to be? I just go through bit by bit and I say, I know I need an x plus 3. Cool.
And then you
I know I need an x plus 1.
and an x minus
I know I need an x plus 3, but I already have 1, right? And I know I need an x minus 1. So I need to have all three of those pieces. Do you see why we don't have to repeat the third one or the another x plus 3? Yep. Okay, so those are that's my denominators and stuff. Okay, I'm going to write my tops, 3x plus 5. I'm going to put the 3x plus 5 in parentheses, and I'm going to put the negative x plus 5 in parentheses also. And then I'm going to write what he needs. I'm going to do that in pink. I'm going to do a pink guy. Okay. Am I going too fast? Okay. Okay. All right. Now, this 3x plus 5. Look at his bottom. He has these two on his bottom, and he needs those 3 on his bottom. So what is he missing?
X minus 1.
He needs an x minus 1, so we're going to multiply him by an x minus 1. Okay. What about this guy? What does he need?
X plus 1.
He needs an x plus 1. Okay, now what do we do?
Multiply. Whatnot.
We're going to FOIL the tops. Bleh. This is where it gets disgusting. All right, let's FOIL that top. So we've got, I don't know, 3x squared minus 3x plus 5x minus 5. Yeah, something like that. Okay, now if we FOIL the second one, what will he be? Minus x squared, okay,
plus 5x.
plus 5x
Or,
minus x, it's fine, we'll do it in the backwards order, 5x minus x and then plus 5. Okay, last thing, we want to put them all under one roof. Whoop. Okay, so I'm going to put all my stuff together on the top. 3x squared minus x squared. I got a 2x squared on the top. Doot, doot. Oh, man.
Plus 2x.
I've got minus 3x plus 5x, that's 2x right here, right? 5x minus x is 4x, so 6x is all, plus 6x. Okay, minus 5 plus 5,
0.
gone. On the bottom, I'm not going to multiply those through. I'm just going to write all three pieces. X plus 3, x plus 1, x minus 1, and he's done. Okay? Beautiful, beautiful. Very good, very good. Okay? All right, moving on. What is this thing? Disgusting is what it is. Gross. What does this bar mean? Divide. Okay? So I have this junk right here divided by this junk, okay? So eventually we're going to keep flip, but I need to, this is like 3 problems in one. Disgusting. We need to, first and foremost, simplify this guy by getting a common denominator, right? Okay, so I'm going to handle him over here. X over 4 minus 4 over x. All right, first things first, I'm going to do plus minus. All right, and I need a common denominator.
4x.
4x, you betcha. 4x, 4x. Okay. And then I've got an x, and I've got a minus 4, and I need to multiply by what he needs. Whoop, whoop. Okay, are we doing okay so far? All right. Okay, what does the x need?
Another
He needs another x, right? Because I'm comparing 4 to 4x, right? So he needs an x, so he's going to multiply an x on the top. Okay, what about this guy if we compare those two? He needs
4.
4. Okay, so this whole top right here, this guy is x squared. This guy is minus 16. So I've got x squared minus 16 over 4x. That's what that top thing is. Gross. That's a difference of squares, by the way, but we'll see if we need that. Okay, now the bottom, 1 over 4 plus 1 over x. Let's see what we've got going on here. Okay. All right, oh, we don't need to change. This is already a plus, so we are good there. Common denominator, 4x and 4x. And I have a 1 and a 1, and we got to multiply by what he needs.
1x and
Okay. Yep, this 4 right here, he needs to be 4x, so we got to multiply by an x. This guy we've got to multiply by 4, right? So we've got 1x plus 4, right? So just x plus 4 over 4x. Yeah?
then what?
Yeah. So this guy, we're taking this guy and we are dividing by this guy, right? This was on top, divided by this was on bottom, yeah? So we're keep flipping. So we've got, whoop. I'm going to take this guy, x squared minus 16. Does that like flash like neon signs in your head? Like, that's a difference of squares. Yeah, let's factor him down. So x squared minus 16, he is x plus 4x minus 4. Okay, all over 4x. Now, I'm going to take this division and I'm going to multiply. I'm going to turn him to a dot so he doesn't look like an x. Okay, dot on the top is 4x. On the bottom is x plus 4. Okay, and now the beautiful part.
X plus 4.
X plus 4 is canceled. Ooh. X plus 4, x plus 4. 4x and 4x cancels. Final answer, x minus 4, and that's all. Look at how beautiful that reduced down. All of that stuff became x minus 4, and that's it. Yes, dear. Oh, hit the refresh button, like the little burp in the corner. He won't work. We were having some internet issues this morning. He'll go, but he's just very, very slow. Very, very slow. I don't know. Okay. I don't know what they're doing. Example 7. They say by method number 2. Let me see if they did any fancier than we would do.
Guess what, Mrs. Bellinger?
What?
I got into winning.
Can't let this die on me. You got into Wayne? That's so exciting. I don't want to do that. I don't want to do that. Okay, let's do this one. Okay, here we go. We got another dividing. Like this whole thing means divide. All right, but if I have d to the minus 2, what's that mean? What's d minus 2? 1 over d squared. Minus 1 over c squared. Okay? All right, that's my other guy, right? What's this one over here? 1 over d minus 1 over c. Okay? So we got our top and our bottom. All right, this guy, I'm going to go plus minus, and I'm going to go plus minus. I always do that every time I have a subtraction. I always do that so I don't forget about my negative. Okay. Okay. All right, common denominator over on the left. D squared, C squared. I'm going to go C squared, D squared. Doesn't matter what order you put them in. C squared, D squared. I've got a 1 and I've got a minus 1. Let's multiply by what they need. Okay, the left side guy, he needs a C squared. Yeah? The right side guy, he needs a D squared. Okay? So, whole bottom on the left is C squared, D squared, right? What will his top look like? 1 times C squared is C squared.
Oh, okay.
Minus D squared. C squared minus D squared over C squared D squared. Boo. Gross. Okay, let's do the right. Boop. Plus. Boop. My negative went away. Okay. All right. Yep. CD or DC, however you want to do that. I've got a 1 and a minus 1, and we got to multiply by what he needs. Needs. All right. What's the left guy need? He needs a C. Right side guy needs a D. Okay, so C minus D over CD. Okay. Ooh, gross. All right, we're dividing those two guys, right? Okay, so let's keep flip. The top one, this left side guy is C squared D squared. Except you know what C squared minus D squared is?
C minus D.
C squared minus D squared. I mean, you're close. That's part of it. Nope.
Negative.
What is he? What is he? He's a difference of squared. Right? 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 What's the square root of C squared? C. What's the square root of D squared? D. One of them is plus, one of them is minus. That was hard to identify. Okay, but we're going to multiply now by the flip. And the flip is CD on top and C minus D on the C minus D on the bottom. Can you foresee that happening? Maybe. Okay, now what? C minus D cancels. Anything else? C plus D is on the top. This guy is not trapped. True? And this guy down here is not trapped either. Right? So I can cancel this C with one of these, and I can cancel this D with one of these. So I have C plus T is the only thing I have on the top. What do I have on the bottom? CD. Right? Because I canceled one of them. Woo! This is a lot. Yeah. Is that a lot? Yeah? A little bit of a lot? Okay. All right. Oofda. Okay. All right. Next. A. We don't want square roots on the bottom, so they say something, this word right here. Have you heard this word before? Rationalizing. This is the last thing of the section. Rationalizing. We don't like to have square roots in the bottom. It's kind of like when you have the square root of like a whole bunch of junk and then we end up pulling things out in front, right? To make it like a proper thing. Or let's say you have like 21 over 5, right? That's 4 1/5. It's like fixing things that are improper, right? That's an improper fraction. Typically, you don't want to have the square root of anything on the bottom. That's just kind of like a understood rule, right? So we don't want that on the bottom. So to get him gone, what we do is we multiply by the square root of x. But if we're going to multiply the bottom by the square root of x, we have to also multiply the top by the square root of x, right? That's how that works. Now, here's how we get away with doing this. If I have the square root of x over the square root of x, what is this reduced to? 1, right? Okay, so look what we're doing. If that reduces to 1, I'm taking this guy times 1. And if you take anything times 1, it doesn't change it, right? So we're not changing the value of this thing. We're just changing what it looks like. Does that make sense? Okay, so if I take him times the square root of x, let's see what happens to the bottom here. What's the square root of x times the square root of x? This is like the square root of x squared, right? 2 of them. But a square and a square root go away, so he's just x, right? Like if we take the square root of 3 times the square root of 3, it's just 3. The square root of 7 times the square root of 7 is just 7, right? Anytime you take the square root of something times itself, it just goes away, right? Like the square root goes away. So it's just x on the bottom. What about 5 times the square root of x? 5 square roots of x, and that's it. Can we do anything more than that? That's it. Done. Now, have we successfully gotten the square root out of the bottom? Yes. And we didn't change the value of it. We just changed what it looked like. What it looks like, right? Okay? Good. All right, now, what happens when we have like 2 pieces that are like whatever, the bottom? Multiply by, yeah, the both kind of, except we have to do the, we've talked about conjugates before, right? Okay. Yeah, we've talked about conjugates before, haven't we? Like how x minus 3 and x plus 3 are conjugates, right? Because what happens when you multiply them together? If you would multiply those two out, the middle two pieces would cancel, right? Like this would be x squared plus 3x minus 3x minus 9, right? The middle two pieces cancel. So that's what I want to have happen here. I want to multiply by the conjugate. What's the conjugate of the square root of 7 minus the square root of 5? The square root of 7 plus the square root of 5, right? That second one changes sign. The square root of 7 plus the square root of 5. Okay. I'll erase this junk down here. I don't know why he keeps switching. I don't know. Anyway, whatever. Okay, are we good? Are we ready? Okay, let's do bottom. All right, let's FOIL him, right? We've got this guy times this guy. All right, let's do square root of 7 times the square root of 7.
7.
It's just 7, right? Okay, what about the square root of 7 times the square root of 5?
Square root of 7 plus
Square root of 7 times the square root of 5.
oh, square root of 12.
Square root of 35. Yep. Okay. What about negative square root of 5 times the square root of 7? Minus the square root of 35. Oh, didn't I tell you that was going to cancel? Silly. All right. Negative square root of 5 times positive square root of 5. Nope. Just 5. Right?
Oh,
Yeah. Okay. He'll be minus, but square root of 5 times square root of 5 is 5. Yeah? Okay. So let's just finish this bottom, right? These two pieces canceled out, so my bottom number is? Which is? 2. Look at that. That's what my thing is going to simplify to. Now, have I successfully gotten rid of the square roots in the bottom? Yeah, he'll have no square roots in the bottom. So that's what we wanted to have happen. All right. Now, what happens when you take 4 times? We got to take 4 times that and 4 times that. We have to distribute them through. What's 4 times the square root of 7? 4 square roots of 7. What's 4 times the square root of 5? 4 square roots of 5. Can you put those two together? They have to have the same back in order to put them together. So that's it. 4 square roots of 7 plus 4 square roots of 5. Now, one more thing. Not done yet. What can I do to that thing?
2 over 1.
I can reduce this guy. Like this would be like 4 square roots of 7 over 2 plus 4 square roots of 5 over 2, right? Okay? And those guys will each cancel, right? So it's final answer.
2 square root of 7 plus 5 square root of 7.
Plus 2 square roots of 5, right? 2 square roots of 7 plus 2 square roots of 5. And then we don't have a bottom, or the bottom number is 1. Make sense? Did I successfully get rid of all the square roots in the bottom? Yeah, by multiplying by the conjugate. So if there's 2 pieces, you have to do the conjugate thing. Over here, you just take them times itself, right? Okay, and again, this guy we're multiplying by this. And what's the square root of 7 plus 5 divided by the square root of 7 plus 5? He'll reduce to be 1. So we're taking that thing times 1, which means we're not changing its value. We're just changing what it looks like. Got it? That's it. Hey, beautiful. Some ugly problems. All right, there you go. Those, I don't know, 6 maybe? 6 problems? Can you handle it? I don't know. Probably. You got a little bit of time. You got a lot bit of time maybe. Trying to get out of here 30?
15 minutes.
Yeah, there you go. You got 15 minutes to work. Boom. We should be done. All right, bye, Megan.